This one is by Federico Tomasetti. The title is The Chisel Method for Writing Parsers. And let me introduce Federico real quick. I have a few notes written here. Sorry. So Federico is the founder of Strumenta Consulting, the company, and the Strumenta Community. He's got his PhD in language engineering, studying between Italy and Germany. As a software architect, he helps clients and partners to assess their situation and identify the best option to solve their problems. Federico is very passionate about language engineering, and he contributes to the language engineering community by writing articles, participating in program committees at different conferences, giving presentations, and interviewing other actors in this field. So thanks, Federico, for being here, and I'll leave you the word.
Thank you, Alessio, for the nice introduction. Of course, it's very hard to follow up to the great presentation from Nico and Jos, so please be kind with me. And today I would like to talk about a method that we developed based on our experience at Strumenta on building parsers. And of course, you may wonder if we don't know already how to build parser, and so if this may seems like a solved problem, a problem that was solved many years ago, and there are reasons for thinking that, because yes, most of the theory around parsing is well established, has been well established for many decades. So of course there are always some improvements, but the basic principles are there. A few days ago, development on Antler 5 started, and so the fact that it's the 5th version of this very famous parser generator give you the idea that there is already some history and some stability. So it may seem a boring topic, and it may seem a very solved problem, and in that sense I think it's right, but in the same sense that flying was a solved problem in 1903, right? And I think it's fascinating to look at what happened the day after the Wright brothers came up with their invention. And today you can actually do that, because you can go online and read the archive of the most important newspapers, from the New York Times to Washington Post or whatever else. And if you look at the newspapers in the day immediately after this invention, it's not like they were, talking about this news or understanding, what kind of impact it could have. Because I think it's fair to say that in the years immediately after this invention, the impact on the life of normal people was basically zero. While, maybe other inventors that were trying to invent the first flying machine were devastated by the news, the reality is that most normal people just didn't care. They were not flying the day before, they kept not flying. And today, instead, flying is a completely different reality. The Boeing 747 alone transported over 3.5 billion passengers over the year, just to give you an idea. And flying is part of the normal life of a normal person. We use that to go on vacation, we use that to attend conferences. It's, not a big deal. And I think that what's changed from 1903 to now is not a change in the basic principle behind flying, but it's just a change in convenience, because now you can go to the local airport, taking a flight, taking a connecting flight. You probably don't risk dying. Maybe you risk your flight being late or day losing your baggage, but that's basically it. And there is a lot of convenience with the fact that they even serve some meals on board, and you even have things like toilets on board. And so these sort of incremental improvements change how we fly. And I'm talking about all of these that is not really connected about parsers, but because I think that we are in a same situation with language engineering in general and with parser specifically, where, the basic principle, the basic ideas are there. What we are lacking is convenience and having also reliable processes so that your risk of dying a terrible death are reduced. But hopefully with parsing, this is not the kind of problem you're facing, but, the flying industry changed completely and gave you way more reassurances today because of better processes. I think this is something that we also should do. Now, what is wrong with parsers, or are at least the problems and concerns that we hear more frequently? Well, to me, it seems that the process for building parser is not very clear. It seems a little bit mysterious, especially for people that do not do that for a living. So I think that many developers who are not developers with experience building parsers are a little bit confused about what a parser does, how it works. And of course, clients typically confuse parsers with transpilers. They do not understand what symbol resolvers are and what role do they have with respect to parsers. It seems also that the process of building parsers seems also based on a trial and error process. So you start, and at some point, someone will decide based on their gut feeling that the parser is done. It's very difficult to teach to someone how to build a parser. So you hope that the junior colleague sitting next to the senior colleague will somehow acquire the experience by osmosis, but it's not really something that you can easily teach, or at least this is my impression. And another problem is with the integration of parser with other components, and we will see why this is a key problem for parsers. So what can we do about that? We think that one step forward is can be done by defining a method that teaches to build a parser in a more reliable way and try to tackle some of the issues that we have with the current way in which we build parsers. And so we define these methods, or formalize what we were partially already doing by improving our processes over the years. And this process is based on three aspects: the definition of a goal, and we will see what I mean in a minute, and then defining a development that is as frictionless as possible. So at this stage, we are trying to serve our fellow language engineers by trying to make their life easier. And then finally, we focus on making adoption easier, because as we will see, parsers are components that need to be integrated in larger application. Per se, they are useless. So unless we ensure that a parser is adopted and integrated in a larger application, you can build the best parser ever, but it's useless. So we will focus on improving, simplifying adoption. Now, saying that we need to define our goal before getting started is the most Lapalissian of all statements. But I think it's important because, when building parsers, I think that our natural tendency is to say, or to think that our job is to take the specifications of our language and build a parser that basically can recognize every piece of code that is written according to the specification. And I think that in theory, this is great, but in practice, there are some problems with that. One problem is that some languages that you may be interested in parsing may not have written down specifications. So in that case, you don't even have the option to work on specification. But another problem that you have is that even when you have written down specifications, there are compilers that do not implement those specifications exactly. They maybe add some extensions, or they do not fully implement the standard. And so you have actual code that is based on what compiler supports, not on what the specification supports. And so if you write your parser based on the specification, it may actually not recognize the code that is out there. Or it may recognize parts of the specification that actually no one is using, and so, is a wasted effort. Also, I think it's extremely difficult to verify that you are achieving your goal, because you can, read the specification line by line and try to implement your code, and maybe even trace back some implementation to part of the specifications. But that doesn't give you any guarantee that you are actually writing a parser that follows the specification. For this reason, I think that a more practical way to define the goal when building a parser is just to start by a set of examples. And in case you are working with a popular language like Java, you can just go on GitHub, take the 5 most popular repositories, downloading all the code based on the license that they have. And you can use those Java files to verify that your parser works. So you can define your goal as being able to parse all of those files correctly. Well, I will add that this is maybe one of the 2 things that you can do to deem your parser complete. The other thing is to have a more qualitative checks on the shape of the abstract syntax tree that you build for each construct. And we will see later an example to see what I mean in practice. The good thing about defining your goal in this way is that you can actually verify if you have reached this goal in a way that can be automatized. So, you can click a button and see if you have a red bar or a green bar. So it's not up to interpretations, it's not up to discussion, it's not up to the gut feelings of someone, studying the sky and say, I consider my parser done. When the bars are green, your parser is done. So we now know where we want to go. Now the problem is getting there. And to go there, we can follow this development process that is based on 2 phases, the parse phase and the refine ST phase. During the parse phase, we aim to mark the first quality check, and during the refine ST phase, we aim to mark as done the second quality check. And during the whole process, we measure progress so that we can update other stakeholders. So let's see the demo. Now, I am less brave than Nico, so I have pre-recorded the demo. Hopefully, you can see the recording, and maybe I will restart the recording. And yes, in this case, what I'm doing is I'm selecting a set of examples, and I'm just running the parser to see which files are parsed correctly. The bar is not totally green, so I've not finished my job. There is a problem. I can interrupt this process, and I can just select the first file. I can open that file by clicking a button in a second panel when I can examine this file more in details. And I run the parser on this. And you see, when I click the button to run the parser is automatically recompiled for me. Then when I get the result, there are issues, so the panel automatically switch to the issue tab. And when I select the first issue, the point where the point is recognized is automatically highlighted. So these are very boring details, maybe for the people that implemented the IDEA plugin. And I can say that because I implemented that. But these are part of making the development process frictionless. It's frictionless because at each stage I know what is the next step, running the test, take the first file that failed, click a button and see where is the problem. And I can do that in a frictionless way because the tools support me and make easy to do that. Then this is a made-up example. So I had introduced an issue in the grammar. Now I will remove the issue. And the issue was just that I wrote that each class declaration should necessarily have type parameters. So each class should be generics. This is obviously not the case. So when I fix the issue, the test becomes green, the test of the specific files. And then magically, all the other files also are parsed and my job is done. Of course, reality tends to be more complicated than that. So you need a qualified language engineer to identify the bug, but in principle, the workflow is simple. So now that I finished my parse phase, because I had my first bar green, I focus on the second one. The second one is verifying that I build a nice AST for each one of my constructs. At this stage, I verify this check, and I can see that out of the 310 constructs that I have in my parser for Java, I'm covering exactly 0 of them. So that is no wonder that my bar is red. So how do I cover constructs in my AST? I just write a simple examples. I try to parse that, and then I look at the abstract syntax tree. Now, in this case, the abstract syntax tree that I get for this example is composed of just two elements, a compilation unit and a class declaration. The class declaration has the name A. When I select it, I see that the right piece of code is selected. It means that the position is recognized correctly. So with a quick look, I can say that this is the AST that is correct, that makes sense for this example. And so I can simply save it. It means that in the future, I will be able to verify that the parser keep producing the very same AST for this example. And now I have example covering 2 of the constructs of my language, compilation and class declaration. Now, there are many authors that are not covered, like abstract. So I can write an element trying to cover the abstract construct. Now, in this case, I can see that now my class declaration is a child of type JAbstract. And now, this is the stage where I would reflect on the abstract syntax tree and make design decisions about this abstract syntax tree. Because, for example, one alternative way to represent this would be to introduce maybe isAbstract flag on my JClass declaration class. So I have this design decision. So at this stage, I will reflect on the different alternatives and decide if I want to keep the abstract syntax tree like it is now or change it so that abstract becomes a flag in JClass declaration. In this case, I'm a lazy person, so I will keep it as it is. Let's say that I'm satisfied with it. So I just save this example. I go back and I should see the JAbstract is now covered. And so this is what I mean by covering the constructs of my language. So this is the end of the demo on the workflow. At this stage, my green bars are green, so I'm happy. My development is done. But while I am having fun completing my parser, there will be other people that will be bothering me all the time asking, where are we? When will be the parser delivered to us? And while this is the case for all software projects, this is particularly the case for parser, which are components that need to be integrated in other applications, because that means that someone else will need to take over, to take this parser and use it to build something else. They could be our colleagues, they could be clients, but in any case, someone else will need to get ready for when the parser will be delivered. So we need to be able to answer them, and we want to give them a an estimate that is based on data and not only on gut feeling. So we want to estimate the progress that we have done on the parser as a simple percentage. And we calculate this percentage based on a few principles. Well, we assume that the setup of the parser is done very easily, takes no effort. So we will assume that when you finish the setup, you're at 0%. When you have completed the development, so all the 2 bars are green, you will be at 100%. Then we know by experience that completing the first phase, the parse phase, takes more or less 70% of the effort. Again, this is based on our experience. Maybe in the future, as we get more data, this will change, but for now, we estimate this. Now, when we are working on making the first bar green, we will be somewhere between 0 and 70%. Where we will be? Well, we could use the number of examples that are currently parsed correctly as a way to understand where we are between 0 and 70%. We just think that it doesn't make sense to do that using a linear relation, because we know that parsing the first examples, it's easier than parsing the last one. As you write a few rules in your grammar, you will cover a lot of very simple examples, and you will get very quickly to maybe 1/3, 1/4, half of the examples, but then the remaining part will get progressively harder. For this reason, we use an exponential relation, and we can share the formula, but just to give you an idea, if you have to cover 1,000 examples at the end of the parse phase, when you're parsing all the 1,000 examples, you will be at 70%. But when you're parsing half of them, you will not be at 25% of progress. You will be not at 35, you will be at 25, so a bit less. And same things for the AST refinement phase. There, we just use the number of constants covered. And so I have a second demo. This is, in this case, made a lot of sense to record this demo because the actual calculation takes like 20 minutes. But basically, we have a Gradle task that verifies the setup is done correctly, and then run, in this case, a parser we built for Java on almost 30,000 examples. So it downloads the file from this repository, verify, all of them are parsed correctly. And in the end, it tells us, the progress as a simple number. It tells us that we are at 69.96%. I mean, this is deceitful to be that precise. But anyway, this value is calculated on the fact that, we are parsing currently over 29,500 examples and just 11 are incorrect. So we are very close to finish the parse phase. And so we are very close to 70%. But this just means that, at the end of each week or even every day, we can run this task and update all the stakeholders of where we are with delivering this parser. So now that we have completed our parser, we can focus on making people adopting this parser. And for this, we need to focus on connectivity, that is by far the most important aspect, and then on documentation and teachability. Now, to understand why connectivity is important, we need to consider that parsers are always used in language engineering pipelines. So they're always used in combination with other elements that consume the output of the parser to build a transpiler, an intelligent editor, or an interpreter. And by the way, the parser is typically attached to a module performing symbol resolution and type calculation. Here we call it semantic enricher. And my colleague Lorenzo will soon give a presentation about symbol resolution. So everything is connected. Now, the first way in which we can make our parser easier to connect is by providing good programmatic APIs, because we will deliver our parser, let's say, as a Kotlin library. Let's say we are building a parser for RPG, a language slightly older than COBOL. We want to implement it in Kotlin. Then someone comes and say, oh, great, I want to use this parser within a transpiler that I want to write in Kotlin, Java, Scala, or Groovy. Okay, you can use it. It has good APIs to navigate the abstract syntax tree, filtering, transforming, generating stuff out of it. Be my guest. Maybe the second client also want to use it from Java, and then someone comes and say, I want to use your RPG parser, but I need to integrate it inside a Python application. So either we convince him to see the light and move to Kotlin, but I think it's not an easy battle, or we use this approach that is based on generating some adapters, and we can do that automatically. And basically, these adapters invoke our RPG parser running on the Java virtual machine in a separate process, get the AST, serialize it, they unserialize it using generated classes, Python classes that are based on our framework Pylazu, that is our framework for Python. So from the point of view of the Python application, they get to interact with nice Python APIs. But the awful reality hidden behind the screen is that we have this call to an external application, we have serialization, we have the need to deploy the Java virtual machine. So all of this is not great. So while this sort of works, in the future, the answer to provide better compatibility will be indeed LionWeb, and we have seen the amazing presentation on LionWeb. So we've seen what is the future for better compatibility of parsers. Then very quickly, as I think we're running out of time, we can focus on providing great documentation, basically sort of specialized Java doc with things like syntax diagram that makes sense for parsers. We can focus on teachability. That means that we can make our, we can offer more reassurance to people using this parser by ensuring that we can teach the method to maintain this parser in the long run to more people. So we can ensure that we will be able to maintain a parser even years from now. And we can also hand over maintenance of this parser to someone else, because we can teach this method and it's not based just on the experience of an individual that could go under a bus. So we have now a written method, 20 pages, maybe will come a video course at some point. We have supporting libraries for 4 different languages. They're open source. You can use them to implement parsers according to this method. We also have a Gradle plugin and an IDEA plugin that accelerate development. And what else? Maybe I will skip this, and just as the final thing, I will just spend a second to say why this is important to us. I think This is important because this make easier for more software engineers to learn how to build parsers and so to become language engineers because we can transmit this method more easily. And it means for people that rely on language engineering solution that they can count on a process that is more reliable. And so this can help build trust for these clients to adopt parsers. And that's it. If you have feedback, I'm very happy to hear it.
Thank you very much, Federico. And we now have some time for questions, so please don't be shy. In the meantime, if there are no questions, oh, there's Jose Martins raised his hand, and I think I can. No. Okay, I think I can allow them to speak.
I discovering new technology with the
That's
webinar platform.
I think you have I think you now can enable your microphone and ask your question. Doesn't seem to work.
Yes, suspense is building for this question, so now the expectations are extremely high.
Ah, no, he said he has no question. Probably was an error. Okay. Okay, so sorry for the mishap. Okay, we have a question from Nico Stotz. His question is, you're using Antler, right? Would the method and tools also work with the other parser technologies?
Thank you. Very good question. Originally, this method ran as a sort of extension of Antler. But in the last few years, we refactored that so that this works well with Antler, but the idea is to build support for other parser generators if needed in the future. Also, for example, using the same framework, we also sometimes write code generators. So we define the AST and then we write the code generators, but we write no parser at all. So in that case, we are not using antlers, we are not using any other parser generator, but so in principle, yes, it can be attached, well, can use without parser generators or with other parser generators. Then in practice, the only parser generator that we use it with has been Antler. Sometimes we have done some preprocessing before invoking Antler. So it does not necessarily start with Antler. So we can have other stages before, and of course we have other stages after, but yeah, it's not by design strictly connected to Antler.
Thank you. Well, there are no other questions for the moment. Oh, okay, a new one popped up. So, Andre Santos is asking, I miss how the AST boundary is defined in the Chisel plugin. You provide a package or so. In your example, are AST being defined by hand?
As part of our parser, we we ship also all the classes defining the ASTs. These AST classes can be written by hand, or when we have integration with Antler, they can be generated automatically by Antler. So the way in which we use it right now is this. We start with an Antler grammar and we get for free an abstract syntax tree. Then we created a tool so that we can add special annotation in an Antler grammar that influence how we can generate some of the AST classes. And so in this way, we can do some adaptations, but we can also have the possibility to write some AST classes manually, where sometimes we want to define the ASTs in a very particular way. So we can also have the possibility to do that. So the process typically starts with what we get for free by Antler, a few annotation, and then we get 90% of where we want to be. And then we customize a few classes by writing them manually.
Thanks. So I also have a question, or maybe two, I don't know. Let's start with one and let's see if other ones pop up. So I wonder how we're dealing with measuring progress when the requirements change over time. I mean, for example, the very definition of parsing some language is a bit fuzzy. So I could, for example, write a parser for a language with macros, for example, and in the first stage, ignore the macros altogether and say, okay, I got to 100% with that, and I will parse all the examples, and I will have an AST, but it won't capture the information of what's inside the macro, for example. It could be just could have nodes that just contain random text. And then in the second phase, the requirements change and they say, okay, now we want to actually look inside these macros and see what's there. So how would how would you define this or measure the progress in the presence of these changing requirements?
Well, I will start by saying that this is one more example of how macros ruin everything, including all of our nice, nice idea where we could predict progress and so on. But no, you're okay. Of course, in the ideal scenario, we know at the beginning what is the scope, and so we measure scope progress with respect of the scope that is known. If at some point the scope change so that maybe we need to parse, let's say that, for example, you start the project and the client says, you know what, I'm not interested in parsing macros, so I will provide you examples where the macros has been expanded and you will need just to parse the expanded code, right? Then after a few weeks, they see that we are progressing too fast, that everything is going too well, so decide to ruin it. Say, you know what, I would like you to parse macros. So at this stage, we will get new examples, including macros. We will run again the progress, and now the scope is changed, and so the progress is now recalculated against the updated scope. And so that will be taken in account. Of course, if, before this change in the scope, it seems that we were about to deliver the complete parser, and then they changed the requirements, and therefore now, we go back to maybe 20% of progress, then we will need to do, to be very clear in explaining what is happening. But in this sense, the scope can be changed and we can recalculate the progress. So in an ideal world, this doesn't happen in a real world, it happens, and we can just rerun the calculations.
Okay, thank you. We have one more question, and then I guess it's probably better to move to the next talk, otherwise we risk, uh, getting too late. So the last question is by Manfred Köthe. Federico, could you please say a few words about the tool setup you used in your demo?
Yes. Now I went a bit quickly on that part, but basically we are using to implement the parser for open source libraries. There are Colasu, Tailasu, Pailasu, and Sharplasu. They are open source, you can find them on GitHub. Then to speed up some of the development, we have also recently built an idea plugin and a Gradle plugin. And at this stage, we have not open sourced them. So basically, this is now an idea plugin that is on my machine. And it's not publicly available yet, but right now, we have been using it, so we're starting the discussion of shipping it to some clients, and at some point, when it crashes a bit less, we may decide to make it public. For now, we are enjoying all the fun and debugging it. I think you're muted, Alessio.
Yeah, sorry. Yeah, thank you very much. There are no more questions. So